Bandwidth for changelog is provided by Fastly. Learn more at fastly.com, and we're hosted on Linode servers. Head to linode.com/changelog.
I'm Jeff Lindsay, and this is Go Time.
It's Go Time, a weekly podcast where we discuss interesting topics around the Go programming language, the community, and everything in between. If you currently write Go or aspire to, this is the show for you. And welcome back, everybody, to another episode of Go Time. Today's episode is number 62. On the show today, we have myself, Eric St. Martin. Carlicia Pinto is also here.
Hi there.
And Brian Kettleson, all the way from Italy.
Buonasera.
I didn't even know you could speak Italian.
I can't.
And our special guest for today is Jeff Lindsay.
Hello.
Now I think we should make Brian speak Italian for the whole show.
Dude, I did. That's all I know.
That's literally every word.
Well, prego and grazie.
In what city are you in?
Milan.
Milan. Nice.
It's beautiful. Right next to my hotel is this building that they have all lit up with, pretty lights and stuff. So I'm standing outside looking at this hotel trying to figure out at this building trying to figure out what it is. So I walked around the block and there's a sign out in front in Italian and English that says this used to be a farmhouse in the 1500s. I'm like, holy crap. 500-year-old farmhouse right next to my hotel. It's just crazy.
Wow.
We have such a short-term view of things in the United States where, the oldest buildings that we see are just a couple hundred years old. And that's only in the rarest cases. Generally, everything's less than 100 years old. It's just crazy.
So, Jeff, do you want to give kind of like maybe a little bit of background about yourself and some of the things you're working on?
Yes. It can be difficult to do that, but
He could tell us, but then you'd have to kill us.
yeah, especially, so I'm doing a lot of open source stuff. Actually, for the past few years, I've been doing a lot of work in kind of the Docker or distributed systems and platform kind of ecosystem stuff. And I'm just now really, and Kubernetes, and I'm really kind of pushing out above that and doing some kind of cooler stuff because it's too noisy. There's too much stuff going on. And, I know how to do things the correct way, but it's really hard to get that out. And, I like things simple and nobody likes to make anything simple. So, so I'm trying to find a new place to innovate, which is kind of higher up the stack.
Explain.
Well,
Please.
Boy, does that
After you get through, yes, we have to go back to that.
So do you want to talk about some of the things that you've done in the past rather than expose this secret thing that you're working on? Like Flynn or Daku? Or my personal favorite, Envy?
Which one?
Envy.
Envy. Oh, you saw that?
I saw it. I had the most fun with that application. I actually used it as a training platform.
Oh, cool. Yeah, that one was interesting because a lot of people it was kind of like for people. I like trying to do kind of mind bending things, and that was kind of mind bending. But then people also really interested in it. I didn't really take it all the way. It kind of comes back into some of my bigger plans, but basically everything I've ever worked on comes back around into my bigger plans. So I worked on Flynn a little bit at the beginning. Doku, that was basically the first killer app for Docker. It's like a Heroku implementation in 100 lines of Bash. It's now more than 100 lines, but it's very cool because it's very hackable. There's tons of stuff in between, stuff like Envy that people don't know about or I don't announce or whatever. I worked on Docker at the beginning, and what did I do before Docker? I guess I worked at Twilio, And I kind of mostly learned. I didn't like working at. I mean, it's great at working at Twilio, being employee 10 at Twilio, but it was my least productive in terms of open source output. And so that was kind of a bummer. That's part of why I left. Um, and then before that, I worked at NASA on what became OpenStack. NASA Nebula became Nebula, which merged with Rackspace to create OpenStack. And then let's see, before that, I've worked on a lot of weird projects. Webhooks is a weird one. It doesn't really, you know, it's a kind of a weird pattern. It's a weird thing to call a project. It's weird. Some people say like I invented webhooks, but I don't think you can invent webhooks. I popularized it. I coined it. I really pushed it to be something that we did collectively to improve how our web applications interact and can be extendable and integrated and more programmable. And around that time, I did a startup way back when I was like 22 or something, called Deja Vu, and it was hosted track and SVN, which actually I was like, this was right when GitHub started, and they were doing such a
Track.
good job.
Yeah,
They're
Oh, I haven't seen that in
yeah.
ages.
One of those things. Yeah. Uh, s- I well, I don't use Track, but I learned a lot of really cool tricks from it, and I actually bring some of those up today, um, architecturally. But made a product called Deja Vu around Track, and then shut it down because I was like, nah, GitHub's killing it. I don't want to waste my time. They're doing it right. So, but that's actually a lot of people. Solomon Hikes at Docker. He was a user of Deja Vu back in the day. It's kind of how we knew each other. Um, a lot of people started using Deja Vu before they were like, no, GitHub. And before that, I did Super Happy Dev House, which was one of the first major hackathons in the Silicon Valley, and did that for 5 years. And that was incredible. I can't even capture how amazing those events were. And then Facebook copied Super Happy Dev House. But most of this time, I've been freelancing or just building kind of open stuff or weird ventures. I don't know. There's a bunch of other stuff.
So you've only done, just a couple things. Yeah.
I made a thing called Local Tunnel, which
local, like the precursor to ngrok.
Yeah.
yeah. And Local Tunnel was kind of the inspiration for trying to find a sustainable model for web apps, the open source equivalent for services. Because if you want to build something and run it on the internet, there's really no way to do that sustainably without running it, building a business. And I think that changes software. And it also isn't ideal for people that like to just create things and put them out there, because now you have to dedicate your life to this, making a business work around it. And there's plenty of things that have value that you can't necessarily build a business around. Um, so I've been kind of working on infrastructure to kind of help make that happen. Command.io is a recent project that's sort of not fully out, it's not out of this kind of private alpha stage. But that's sort of a recent project. I bring it up because I was going to try and validate this idea of, can we build a service that's actually, it looks like a startup, but it's actually a sustainable self-running service where all the operations is also open source, and using mechanisms like chat ops and versioned, state and configuration, and kind of automated accounting and stuff like this, to make a system that just runs, and an open source community uh, is the only thing keeping it going. So there's no like person or business entity that will, I don't know, get bought and shut it down. Like so many great things that have been built, like Parse and some other stuff. It's like the business aspect of software can be really harsh sometimes. So spend a lot of time thinking about that. I also think a lot about making, just in general, I think this is me trying to encourage everybody to be more of a hacker builder type. I really want to make more of the world uh, and even the just computer systems that we have more programmable, more extensible, more scriptable, more customizable. We become really dependent on this idea that application vendors and software developers are how we get functionality from the world of computing. But really, we should be able to do anything because it's software. Like you can do anything, but it's not that way. And even as a professional programmer, there's this idea, this kind of ideal that we have this great kind of imagination compiler, and you kind of come up with an analogy like Legos. You can just kind of like compose things together and throw them together, and that's not really how it works most of the time, unfortunately. To the point where a lot of really creative people, technologists and programmers, they think about they see something cool like, oh, I can make this system better, or I could automate this or whatever, and then they don't, because it actually is quite a bit of work to not just build it but then maintain it and all that. So that's really unfortunate, and I spent a lot of time thinking about that and trying to make better building blocks, and so that's a common theme of a lot of my work.
Do you ever think of using artificial intelligence?
Yeah, I actually, a lot of other people are thinking about artificial intelligence, and there's so much value you can get out of not using artificial intelligence, just basic automation techniques. Um, it's like there's so many simple things that it's like, oh, you could imagine modeling that in a few lines of code. Um, and instead, people are trying to build AI systems that are trying to like understand what you're saying, and then try and put together some list of like super limited uh, possible ways to react. When in theory, if you just gave people, empowered them to have the tools to really easily just build their own kind of automation and stuff, I think that is gonna you'll get more bang for your buck. Um,
Mm.
though I think in the long term, AI will have like a helping hand. Right? It's more of a tool than a solution. A lot of interesting stuff going on though.
Yeah, that's a good way to put it. More of a tool than a full solution. I've been thinking about the idea of the composable software recently. I found and this is, I promise this isn't an advertisement, but I found Microsoft Flow, and I had never seen it before, or anything really like it. And it's just drag and drop, clicking on stuff to make crazy blocks of things happen with software. I mean, you want every time you save an Excel spreadsheet, it can read the value from column 7 and send a tweet about it. I mean, it's
Hmm.
really cool automation, and I'm kind of surprised that it hasn't caught on more. I had never heard about it until I started at Microsoft. That's pretty easy stuff for your average data worker to just go use without calling IT.
Yeah, yeah. There's some great. I kind of think of them as walled garden experiments, and a lot of them. Part of it is they're designed for. I mean, I love any kind of experiment in things to facilitate end user programming, things that make it easier for not necessarily programmers to easily kind of program things either visually or whatever. Um, but the problem I have with a lot of those systems is they become their own ecosystem. They become their own walled garden. And so my way of thinking about building systems is a much more open kind of system. Um, some friends and I were working on this kind of project that we're calling web pipes. It's kind of like formalizing some of the webhook stuff to try and come up with an open uh, kind of an open source spec for building if this then that type systems, and it was layered in such a way that you're not just creating these um, formal abstractions for this particular system, but it's at the end of the day it's just an API, and if you really want to get into it, you can just write some custom code to write a custom block or a custom trigger. So making it so that you can kind of work at it as an expert and kind of work at some of the kind of lower level interfaces, as well as having kind of a high level graphical interface, graphical representation of things. Something that kind of scales to both, because I think uh, it's it's hard to bootstrap a community. It's hard to bootstrap something like that. So being able to actually be something that like a professional programmer would want to use as well as an average person, which is a challenging thing, but I think it can be done with design.
Nice.
a lot of the stuff that I've worked on, Docker, things like this, those were pieces to something else that I wanted to build. The way I think of things is, and I have frustrations with this because this is very the conventional way of thinking in software and actually most fields is a very relative to the current um, state of things. So it's like you're trying to solve immediate problems. Um, when it actually goes a really long way to step back and say, let's say we started over. What do we actually want? Can we envision it? Can we describe it? And that gives you kind of a roadmap to at least start saying when you're making specific solutions to things, is this taking us closer to where we want to be? Or is it just solving this immediate problem? And so, I have kind of all these ideals of a, world where everybody's empowered to build things very easily and tap the full potential of computing and automation and all of this. And it requires a lot of infrastructure to get there, especially if it's something that is more than just a walled garden. It needs to be built up from other kind of building block components. So, I when I first found App Engine, I was in love. I was like, this is amazing. I can build applications and hit a button and not worry about the operations. In some ways, uh, and so that led to this sort of App Engine and Heroku. Working at Twilio, we talked a lot about wouldn't it be great if we had our own Heroku, and that led to okay, well, how do we break down the problem? And that got into kind of distributed systems, but the main primitive or building block that I saw to facilitate building your own Heroku was basically Docker, right? A container manager primitive that was a higher level kind of primitive than LXC. And so running into Solomon, kind of him thinking about the same kind of thing. It's like, no, this is it. Um, so then that was building block was out there, but then you had, so many other things that you need to develop for building kind of these kind of distributed systems or a system that you could build a good Heroku or App Engine on top of, which a lot of people started the floodgates opened and everybody started building stuff, and Kubernetes has kind of risen to the top in a lot of ways for getting us to that kind of cluster manager abstraction level, and other kind of things kind of working on serverless, which is really just kind of like a different way to think about platform as a service stuff. um, and for a long time, I had all the components like how I would build Kubernetes, but I really hesitated from building them because I knew so many other people were building them, and it would have been I'm not getting paid to do it, so it's like I don't want to waste my this precious commodity when I could be building other things or whatever. Um, it's frustrating though to kind of know that you want something in a particular way and then it doesn't happen exactly as you want, but as long as you kind of focusing on the bigger picture, it helps. So,
So, what's your opinion kind of on where we're going with, say, Kubernetes? Because you're interested in distributed system stuff and solving things at a higher level and abstractions and building blocks. How we're getting to the point where like we're trying to make like the running of Kubernetes or getting it right, where it's a commodity, where it's easily you can get a Kubernetes cluster pretty easily. Building like application abstractions on top of that, like we start seeing more and more of like the operator pattern and things like
hmm
that, where you can actually abstract away the application and build things like that. What's
yeah.
your thoughts on that?
I love the operator pattern. That's very much sort of turning operations into a building block. Having Kubernetes as kind of the standard interface to facilitate it. So that's really exciting. I want to see operators for everything. Um, I have my problems with Kubernetes is too complex. Kubernetes is yada yada yada, and some of these can be solved with higher level abstractions. I mean, one of the projects that I would love to do that I just can't find uh, it just doesn't make sense to make it is the Doku of Kubernetes that kind of sits on top of Kubernetes and gives you that kind of like very lightweight but very hackable and customizable. Problem is Kubernetes is already very extensible, but it gets very complicated very fast, and there's still a lot of stuff that you need to kind of set up and configure, with Kubernetes out of the box. And the way things are moving is like Kubernetes is probably just going to add more stuff to try and solve those problems, but it's just going to make things more complicated. Um, I mean, that's usually what happens with software like this. It happened to OpenStack, it happened to Docker, it's happening to Kubernetes. It's really unfortunate, and a lot of it, to me, I think, has to do with corporate interests and stuff like that. Like, I kind of think VC funded open source is one of the worst things to happen to open source, but maybe that's a different conversation.
Yeah, I think outside interest, and I think everybody kind of has their own vision of the future and direction, and they're all trying to slide in the building blocks they need for that vision. And then we end up in situations where there's so many options, the kind of analysis paralysis or the paradox of choice, where you're looking at all this stuff and you're like, should I use a stateful set, or should I, or pet set, because it used to be called that, but they're both in there now, and there's confusion, and then I think people just back away. Like, I'm a
Mhm.
big Kubernetes lover, but I also think that Kubernetes is amazing for Kubernetes related problems, right? Like, I think there's nothing wrong with if your infrastructure is not complex in that way. Like, there's nothing wrong with running a couple of containers and Docker and things like that, and load balancer in front of it, and problem solved. Like,
Totally.
why
Yep,
support all of that?
definitely. Um, Most of the time when I try and get people's vision of the future, it's not really that much further out from the existing scope that they're working in. They might want certain different ways of doing things at a lower level, because they're fans of System D or something like that. It's like, okay, so your end goal is we're using System D or something, and it's sort of like, well, but that's like, I don't even care about that level, that part of the stack now. Like, can't we just move on? Um, and it's not even like some people are like, okay, now after platform service, we have serverless. It's like, okay, we're moving up the stack. But that's even like, again, like very sort of just like one step past. The idea is to like think, well, what do we want? I mean, I go as far out to kind of the kind of society that I want to live in, and go backwards from there. But um, I don't want to get into that. Actually, Kubernetes isn't super interesting, um, to me anymore. Uh, it's kind of more like in the same way that I kind of quickly moved on from Docker. It's like, okay, I know how to do stuff with this. It's a solved problem. That happened really quickly with Docker, and then it was just really painful to sit through years of the industry kind of catching up, and even a lot of the best practices, that I had kind of figured out early on and talked about and shared and built tools like the Alpine container image like that. We found that and we're like, this is perfect for Docker. So we brought Alpine to Docker. Before that, like I was working on a BusyBox instance that had a package system, because I was like, you want BusyBox minimalism, but you don't, but you want to have packages. So there's a space between like doing a custom single binary type of like Go thing and something that could run SSH or Bash or whatever, but not have to like rebuild a custom BusyBox just to get it. Um, so one of my early Docker containers was a BusyBox container with OPKG, which was a package manager for routers, I think. Uh, and then discovered Alpine. I'm like, this has everything, with a couple of caveats, but this is great. And now it's like now luckily everybody's kind of using Alpine as their base image for because it's like you're shipping containers around all the time. Why are you sending these huge images? Um, and I'm also really pleased to see stuff like webhooks. Like they're everywhere. It took 10 years, but uh, when I was working on webhooks, I was building a lot of prototypes, adapters to give you webhooks for various things, kind of as demos to show people like, oh, this is kind of what you could do and how easy it is to use webhooks to get certain events and stuff like this. So I made like a mail hook gateway and a Jabber hook. Now a lot of like APIs that do mail will provide those kinds of things, but cron one, a bunch of things like that. And I was putting them all on App Engine. Um, and one of the things that seemed to make a lot of sense for webhooks is, well, you want to write little scripts little handler scripts, and it's got to be easy because I just want to be able to wire something up and be done. So I'm basically imagine like the pitch was a paste bin, but the code that you put in it actually runs. So this was a project called Scriptlets that will actually run on App Engine. So it was kind of a very early kind of serverless type of thing. And there were a lot of those kind of like hosted code type of things back then, and they were all positioned as like, oh, build apps with. I was like, no, this is their benefit. Like a lot of the one like AppJet, and I can't remember. I used to have a list of these that let you just write code and hit save, and there's a bunch now like AppKit and some interesting ones that have other cool properties. But Heroku originally was that as well, where you could write a little bit of code and handle webhooks, but they were all building things to build apps and nobody really wanted that, so a lot of these went out of business. And then AWS comes along, and they do Lambda, and they make it specifically for event handling, a lot for their internal events, but also webhooks, and it can do HTTP. And the funny thing is and then everybody wants to build apps with it, which is kind of hilarious. um, but even Lambda is not as it's not that like paste bin kind of experience. You can just like write a little bit of handler code and hit save. You see that in like pockets. Like I'm sure Flow has that kind of stuff. Some of the stuff that Microsoft doing is really cool. Like their durable functions is something that I've been working on for a long time, sort of on the side. This idea that workflow automation is a really big thing. Being able to write a program that interacts with multiple people over maybe a week, send someone a task via email, they say they finish it, moves on, does some automation, and then gets approval from a handful of people or majority vote of something. Like that gets into some really interesting things in what you can do in terms of automation of groups, not just businesses. And so, um, I most workflow automation stuff is just you're kind of defining this big state machine. You do it in this kind of like DSL type of thing, and it's kind of painful. And I just imagine being able to write, some JavaScript where you get to a function, and it doesn't even have async wait, or maybe it does, but you get to a function that's like, okay, this function is going to email people for approval, and then it's going to wait until it gets approval from those people. That might take a week or a month or a year, you don't know, but as soon as they do, this needs to go to the next step. So you can start programming in the large with simple JavaScript or something. And this finally became possible with some of the stuff that was done as first kernel extensions and is now integrated into Docker. You can actually persist a process, pause a process, serialize it to disk, any process, and unserialize it, and it'll start running exactly where it was. And so with a little bit of kind of infrastructure around this, you can build something that is that. You could write some JavaScript that will run until it does something where it needs to wait for an event, go to sleep, serialize it so it doesn't isn't running anything. It costs nothing. It's just storage of this serialized process. And then when the event comes in, it unserializes it, runs it, and goes on as it were. Um, that's kind of what durable functions give you. And so it's validating on one hand and a little. So, but I want to talk more about Go. This is Go time.
Well, that's perfect. When did you start Go? When did who introduced you to Go, or was it something that you stumbled across and found on your own?
I used to watch a lot of Tech Talks, Google Tech Talks. And Rob Pike gave a tech talk in 2007 in which he talked about NewSqueak. And NewSqueak was, I feel like it's not as well known as it should be, but NewSqueak was very much which has nothing to do with Squeak, but NewSqueak was very much Go, but with kind of a different implementation, different, you know, slightly different syntax. But all the patterns that were there, this concept of Go routines, and even a lot of the Go conventions were in the language. And he described how he, doing concurrency in a system like this. And I was like, oh, this is really cool. And then not long after that, he worked at Google and was started Go. Um, and so it was kind of that talk that was kind of my first like, oh, this is really interesting. And then, of course, the fact that Go had this kind of philosophy that it does, it kind of came from way people did stuff at Bell Labs. which is very much kind of like that Unix philosophy, building simple systems. There's sort of a design. What's the word? Uh, there's a certain amount of
Ethos.
discernment. Well, there is a clear ethos, and in it is sort of this like, we're actually going to be thoughtful about things and try and build. Uh, uh, I mean, the way I describe it is very generative primitives, right? Like the people that want to do like a set library for Go. It's like, well, you kind of missed the point. Like, I know it's a little bit extra work to do a set using a map, but you can just do a set using a map. We don't need this extra bit of abstraction and this other library and this whole dependent. And that's how you get kind of the mess that is the Node and JavaScript community, where they build these like micro libraries for things that just complexity explodes. What I want to see are less libraries, and one of the ways that I think that that's possible. Um, how can I try and describe this? So when I was working on webhooks, there was this like kind of metaphor, this story of, you talk to an API. The API doesn't really have a way to talk to you. You talk to it using HTTP and then whatever kind of conventions on top of that. It could just talk HTTP back to you. Um, assuming that you have kind of an endpoint somewhere on the internet, because maybe you're an app, maybe whatever, um, and that was kind of a realization that it's kind of a two-way conversation. The weird thing is that almost all programming, the way you think about it, is like every library is a collection of functions and objects with methods that you call, right? Uh, and that's kind of the main paradigm of reusable software, is exposing collections of functionality that you call, and that you kind of dominate the conversation. So it's basically, the analogy is having a kind of a one-sided conversation with somebody. It's like you're talking to somebody, and pretty much all they're doing is acknowledging you, maybe looking confused, like that's returning an error, or if you ask a question, they answer it, but they aren't a real participant in the conversation, because software doesn't really have a great way. I mean, it does, but it's more of like a cultural practice. We don't design software, reusable software, to have a conversation back with us. And that kind of gets into some of the stuff with interfaces, which in Go is just so beautiful because you can define an interface, and there's very little extra work you need to do to take advantage of interfaces. And interfaces are magical. It's like one of the coolest tools in software abstractions ever created. And we don't use them enough in Go as it is. But we can actually, like, imagine if we actually really use them to do kind of two-way conversations. Um, and so that's uh, kind of what I've been working on, how I've been writing software for the past few years, is writing more software that expects to talk back to you using a particular interface. Um, in a way, exposing a bunch of hooks for various things. So again, it comes back to hooks, which to me is a big theme in my work, in terms of like making things more extensible, more tightly integrated, uh, and you get, when you have this, like, the software that you get is so much more composable, so much more reusable. Um, this pattern, the way of thinking about this, actually came from Track, that Python piece of software that nobody really knows how it works except for Track developers. And as a person who's building a startup around it, I had to know how it worked. And they developed this over time, this really kind of elegant kind of component system, where every major piece of function, because it did a lot. It had a wiki, it had an issue tracker, had a timeline, a code browser, it had search, it had, and you could get plugins that would make it do more. And the way they achieved that was by building everything as a component. And not only would it have, an API, so, and it's a class, it's an object, a singleton, the wiki system is a single object, and uh, every component could have extension points, which are basically hooks into that subsystem. So, for example, if you wanted to make it so that when code is checked in, it will close the issues that are mentioned in it, that could be implemented in the issue tracking system instead of being hard coded with the uh, versioning system. It just has a hook. When code is checked in, you know, have a look at what's in it. And then another system can be like, oh, it says closes number 14. I'm going to close that. So you can get a better separation of concerns and really big build kind of these components that map to functional pieces of functionality in your applications. And then those extension points can be exposed to the user to do custom. You could expose them as hooks, like shell hooks, like shell scripts, or you could expose them over some custom plugin protocol, or there's lots of expose a JavaScript interpreter, and that you call functions in there. So now your users can script stuff in your application. So this turned out to be an incredibly powerful, simple idea, like webhooks. And I've been trying to find a way for like the past 3 or 4 years to do that in Go, in a Go idiomatic way, that also has some of these other properties of building kind of component oriented software. And I actually finally have a library that does it. I've been working on it for a while, and it's not a lot of code. That's the whole point. Is like it's really hard to build software. Like ideally, software is as little code as possible because every line of code is a liability. You know, so it's a really simple library. I just put it up in an example app and all this, and so I guess like this is the official announcement of it. It's called Com. It's kind of a stupid name, Glider Labs Com, and it lets you build component-oriented software in Go using this kind of interface-based hook stuff and dependency injection and configuration. Um, is really cool. It's really abstract though. It's kind of hard to describe, and visually it's a lot easier. But if you go to the project, you can look at the examples and stuff. I built a wiki in it the other night, and the wiki is like 200 lines of code because it's using a lot of reusable stuff.
I saw Com a couple weeks ago, probably when you first pushed it up. I'm not sure. I have a habit of cruising through GitHub late night looking at interesting Go projects. And I didn't quite understand it until you put the wiki example up, and now it's much easier to understand. So maybe it would be useful. Oh, I think there is already a link on the Com repo to the wiki
Yeah.
example. The wiki example changed everything for me. Before that, I was just like,
Oh,
what is this?
yeah. I mean, that was the challenge. Is it's normally Go libraries. It's like, oh, just go to look at the Go docs, and that was like the worst way to approach it.
Hmm.
Especially because now you really only use one method. It's basically a one function system, and everything else kind of happens magically with reflection and conventions and all this stuff, and using interfaces. And then all the interesting stuff is done with components built from that. And so there's a separate library that's called Standard Com that has you know stuff that I do all the time that actually sounds like, oh, why would you need a component for that? Like there's a daemon manager that will run services so that if you have anything that needs to serve something, this will run it after some initialization hooks that anything can implement. HTTP then uses that, and then there's a whole component for building HTTP, and it's like, oh well, but the built-in, it's really a wrapper around the uh, standard HTTP library that does some stuff that basically everybody ends up having to do, but then where it gets custom, there's a hook for it. And then from that, I built, sessions and authentication using Goth that actually has like, oh man, like 40 providers or something like that. So you log in with GitHub or whatever, and all of the usually when you use Goth, you have to set up the handlers. They have some helper stuff, but they're actually either broken or do things differently. So you have to kind of integrate libraries. That's always the thing. You always have to integrate libraries, which is really annoying. You have to set them up and tell them how they interact with the other libraries. And so if you build with this system, it becomes real easy for libraries to almost self-assemble. And you're just using Go interfaces as the mechanism for doing this. So then I built a kind of a, these are all kind of more experimental stuff, but a console component that gives you, basically wraps up the authentication. So you have a page where it says login, authenticates with whatever provider is configured, takes you to this kind of like very admin-y looking thing with a top menu where you can configure what it says the title is, and the menu items are actually provided by hooks. So when I create the wiki system, it's like, okay, here's the menu item. I want a wiki, so it says wiki, and that links to a page that then it renders part of the page and then hands the rest off to the wiki to render its pages. Um, and so it's a really amazing way to write. It feels like we never had composable software before, and it's such a different way of building. I mean, not different, it's just like it feels so good, um, working with this system. It's taken years to kind of get right and reproduce and go, but I think I'd finally done it. So now the idea is I'm going to build a bunch of stuff with it, because that was the whole point, is by having reusable components, I can easily throw together systems and ideas and projects. So one of the things that I want to do with this is rebuild Command IO from kind of from the ground up, like based on the existing code base, um, in actually public, like open source from the beginning. And I've been doing a lot of streaming so that people can kind of watch while I work on it. And so I'm going to try and build every component, from the ground up, of building a Command IO system. Which, by the way, is this kind of like, it's sort of like functions as a service, but it's commands and over SSH. It in itself is kind of a funny. I don't know if anybody's seen Command IO.
I looked at it, but didn't really get the use case for it. It seemed like there was the ability to run remote commands, but no persistence or no file storage. I was
Uh-huh.
confused. Help me out.
Yeah. So, a lot of kind of functions as a service is usually designed around HTTP. So you're writing web handlers, and you can kind of shell out and kind of do whatever. If you have containers, it's usually, these things aren't made to work for. Let's say you have a script. A lot of people write. A lot of people's automation in their companies is based on Bash and or various scripts. And in order for people to run those scripts, they have to download the script, or install it as a package. Make sure you have all the dependencies, and of course, you're not running in containers because you're talking about people's development environments. So everybody has to have the right dependencies. And then if there's secrets, like let's say your tool is going to go do stuff with AWS, and it needs your AWS credentials, and you have to share your credentials with everybody for it to work. Um, so this was a way to basically say, here, you can put that script in the cloud. It'll run in the cloud. It'll run with secrets that you specify that nobody else has access to, and you can run those commands with SSH. So you can say SSH, my deploy site command for your company or your app or whatever, and it'll go and deploy from anywhere. They are stateless, in that you don't have, but you can pull from Git. You can kind of do anything you want from the command line. However, one of the things that I've been working on for a while is a way to expose your current directory to it. So now that would open up the possibility of writing tools that actually interact with the file system and particular files in your project. So again, it's kind of like the speed to get somebody working on your project. Have all the right tools and stuff like that. You can actually just put all those in the cloud, and then just they kind of run a command, and it's working on your file system, but the code is executing somewhere else. Um, and so it's run consistently, and any secrets or passwords are kind of protected. And you can share access to commands. So it's a really powerful. It's a dumb primitive. I did it because um, it's not like the most amazing primitive, but there are use cases, especially when it comes to groups trying to automate things like deployment in a kind of opsy world. Um, and you could easily throw a Slack interface onto it, and now you have chat ops type of stuff. So functions as a service, focusing on like command line, is really what it is. And yeah, it's a great tool. So I was gonna kind of rebuild that using this components. It's using an older version of it, and isn't as componentized as it could be. But this, is a way that people can kind of see, oh, here's how you'd build an application or a system that's fairly complicated, not super complicated, from scratch using these kind of components. And a lot of those components will go into future projects as well. Um, a common one that we have besides HTTP is SSH. We have a really great SSH library for Go. If people don't know, Glider Labs SSH. It wraps the existing crypto SSH library and gives you an interface that's actually, it looks a lot like the HTTP interface for servers. So it becomes really easy to build SSH servers and do stuff with SSH, which is a really cool protocol, by the way, because it can do connection tunneling and you know all kinds of neat stuff. Like as a protocol, has a lot of interesting primitives inside it. Um, Brad Fitzpatrick said he thought it was dope. So I think that's good. He said it was refreshing to see good API design. I was like, well, I'm just copying HTTP, so
Yeah, I want to say I've messed with the SSH library. It's been a while. It's so hard to remember where you pick up the libraries from. You find something cool, you're like, oh, this is awesome, and then you remember who wrote it later.
I played with it just a couple weeks ago and I had a blast. I did things that were completely not SSH with it, which I think was the best part.
yes. I do that all the time. I love doing non-SSH stuff with SSH. It's a great protocol. It has it's this whole layered approach where it has kind of authentication stuff, and that's all pluggable, and then it has a connection layer where you can kind of tunnel multiple connections, and then it gets into specific oh, this is an SSH session, or you can do stuff like not just tunnel connections, but basically implement other protocols, sub protocols in it. It actually looks a lot like HTTP2. Like it has a lot of the same primitives in terms of kind of instead of TLS, it has its own security authentication encryption mechanism, and then the streams in HTTP2 map to the connections streams that SSH has. Um, so I was using it for all kinds of crazy stuff. It's a really great protocol, and then of course it all works with SSH keys, which everybody's pretty comfortable with. So
We hope. There's...
we I actually rewrote local tunnel using a library that I built on top of the SSH stuff, and it turned local tunnel into like a 100-line program. So to me, that's always an achievement when I can build a non-specialized library that allows something before, maybe something I made before that was very complicated, to be represented in a very simple way. That's usually a good sign, I think, of a good building block.
Yeah, deleting code is always awesome. And I love when people create things that are beyond what I thought, right? Like you build this really hyper-focused, specialized thing, and then somebody comes along and builds some kind of abstraction that takes away 90% of your complex code. And you're like, wow, I didn't really see it at the time as something that was way more general.
Yeah.
And then you get to kind of just delete most of your project, include some kind of working component.
And in Go, that usually happens when you're using interfaces, because having interfaces for stuff is really great. I was just saying the other day that the Affero file system project, that should be in the standard library. There should be an abstraction for file systems, because there's so many things you can do with it. Not only do you normally end up having to mock the file system somehow anyway, but for example, a lot of things are programming to that interface that you can just swap out with something that, for example, I'm going to be working on a project where Hugo, right? I use Hugo for all my sites, and the way that I, normally the workflow is I clone the project locally, do some edits, run Hugo, check it out locally, and then there's a script where when I push the code, the CI will automatically deploy it to the GitHub Pages branch to deploy it. And a lot of pieces could be removed from that if you just replace the file system that Hugo works with a file system that talks directly to GitHub. So building a file system implementation that actually is a GitHub repository. using the GitHub API. Uh, and that way you can write that and you could almost literally drop it in to the Hugo, at least the Hugo library, and say, here, use these two file systems. And it reads files in from your master, and then it writes files directly to your GitHub Pages branch. Right? That's beautiful. Um,
I wonder if like a stopgap like between that would be like using Fuse.
yeah, stuff like Fuse is really cool. It all depends on the requirements that you have. Uh, Fuse is, it requires kernel extensions. I can tell you about something, kind of an alternative to Fuse is using 9p, which is uh, kind of an NFS, a simpler NFS that was developed by Bell Labs, and it was used in like Project 9, all their file system stuff. But so this was a remote file system protocol. It's actually really simple because NFS and all these remote file system type of stuff are just interfaces. They look a lot like some of the I/O interfaces, or like the file interface, um, but it's just a protocol for sending messages that are calls to those, and they return back the bytes. So the cool thing about 9p is that it already is in the Linux kernel. You can just mount directly. You don't have to install anything extra. You can just, in most cases, mount a 9p file system. So uh, this is how you can kind of do custom file systems without having to do Fuse and do extra, run an extra daemon and have a kernel extension installed. Just use kind of a network file system API, even if it's local. And so there's a really great 9p protocol project that one of the guys at Docker made, and it was missing an actual server implementation, so I wrote that. And I actually ran like Jonathan from Flynn was actually thinking exactly the same thing. Oh, you can use this to do a better way to deploy your current directory instead of having to tar it up and then stream up the tar like everything that doesn't do get-based stuff. You can just say, here's a tunnel to a 9p file server that's serving the current directory, and then you get kind of a lazy load way to access the files. And in theory, it'd be faster because it's kind of like the equivalent of streaming the files. And so he was thinking the same thing and found the same library, and we actually, you know, worked. It's kind of it's been a while since we catch up every now and then, but then we got to kind of collaborate on this, a little bit of code fixes to this. Um, and then, so yeah, using SSH, you can then tunnel that 9p connection through it. And so that's how Command IO is going to expose your local directory to the container on the remote side in the cloud using 9p. So Fuse is really cool, but 9p is also really cool, especially because it doesn't require extra stuff.
That's crazy awesome. I just read an article that I think I found on Hacker News maybe a week or so ago on building your own 9p service. And it was one of the best written articles I've ever read. I know I tweeted it. I'll have to come up with the link to that. It was a really good article.
Yeah, I'd like to see that. It is a really simple protocol. It gets the job done. It's pretty simple to understand. And this library that I found, it was implemented, beautifully. It's like, here's an interface that maps to the protocol's interface in Go. So there's a Go interface for it. So it's very easy to write a client or a server because the client just basically can talk to the interface. If you want to implement a server, you implement that interface. If you want to make a bridge that's a client and a server, it's very easy to do that with this interface. So interfaces are amazing in Go, and they aren't used enough. I'm always frustrated when there isn't an interface and I wanted to wrap something. I'm like, oh, I could fix this if I could wrap it. But if I wrap it, it's a different type. Whereas if it was an interface, I could make my own implementation that wraps the existing implementation and changes it, and then it would still work with everything.
Yeah, I think it's hard too to figure out when the correct time for that is, right? Because you have the other side of it too, where you make everything return an interface, and your interfaces aren't really figured out yet, like when you're that early in writing code. So, and then if you're always moving on to new features, you never really get to go back and recognize where you kind of have very, very similar patterns that could be abstracted out into interfaces.
Yeah.
except for your obvious ones, like you're
Yeah.
doing bytes and stuff like that, like return an IO writer, or reader.
Yeah. And so that's why I wish more interfaces were in the standard library, like the file system interface that the Affero project does. Um, it's basically the Go developers helping you design your interfaces. It's like, oh, you don't have to think about how you would do IO stuff. Like we've already come up with a really elegant solution. Here you go. Just use this. Um, that's where it's hard. Like designing APIs is hard. It takes a long time to understand the domain well enough to be able to create the simplest uh, API for it. Um, that is, expressive and lets you do everything that you need to do, but is also very simple. Um, and takes a lot of time. Most developers don't have that luxury, unfortunately. Even I have a lot of time in the sense that, like, okay, I have enough money, I can spend a lot of time on something. Um, but even then, I'm like, it's taking a long time. It takes a long time to get good API designs. Which, maybe stuff like the Go Commons project is a great place that we can experiment. That current conversation about the loggers, maybe not that one specifically, but that's a great place to start talking about interfaces, not even implementations, but just interfaces for things.
So yeah, that was one of my most exciting things about the Go Commons idea, which was um, everything should start with an interface, and the implementation should be second. Everything
Yeah,
should have an interface.
yes, yeah, that'll be exciting. Standard com is kind of like that in that I'm developing a lot of interfaces for the hooks. And the neat thing about the components in com is because so I had this kind of hypothesis, when you're writing reusable software that, your ideal is that it's simple, both in the API, but also implementation. Like it should just be as simple as it can be, and composable, right? Kind of Unix philosophy, right? If you introduce hooks and extensions, whether it's callbacks or whatever, you're able to allow it to express a lot more things and let it do more things than if it didn't have those. And so that actually reduces the amount of code that you need. Because a lot of times you can say, oh well, this is relatively common, but not common enough that we actually put it in the library. Um, but we'll put hooks in there, and then maybe someone else will write an implementation. And they can, so it lets you decouple things a lot more, and the end result are simpler components, simple pieces of code, which then you can say, okay, if this doesn't meet my needs, I can re-implement it because it's not that complicated, and I can use the same interfaces, and everything will work with it exactly the same, assuming same guarantee of semantics. But um, and that's really cool and powerful. So I don't know. This is it's kind of part theory, but I've been really enjoying building applications in this paradigm, and it's all thanks to interfaces.
The interfaces are like the be all end all of Go for sure. Well, I think we've talked so much that we are pushing our luck in terms of recording time today. So we probably need to move on to Free Software Friday and skip the news this week because I know we've got a hard recording stop in just a few minutes here. So does anybody want to start off the Free Software Friday bits?
I'll kick mine off.
All right.
So I didn't do a lot of development this week. Well, a little bit. So I've been in New York City at this open hack thing that Microsoft's been hosting, which is like a cool little hacking challenge conference. And I'll like write up something a little bit more about that. But it's been super fun. But as part of the thing, we had to like deploy Kubernetes cluster with metrics and stuff. And the Prometheus operator by CoreOS is like badass. Like it's the first time I've used it because like all the Kubernetes clusters I've set up and administered, prior to this. But the pattern is really, really awesome because it actually uses custom resource definitions, and I kind of hinted at this in our conversation about like building abstractions using the operator pattern. So like literally to get our service monitored by Prometheus in our Grafana graphs, sidecar process that scraped the stuff over a custom protocol, use the Go library, which automatically gives you an HTTP listener for Prometheus with a /metrics endpoint to expose the gauges. So boom, that part's done. And then in order to get Prometheus to find it, it's just because they use CRDs, they have like a custom Kubernetes resource called a service monitor, where basically I told it the label to look for my custom service, and it automatically knew how to find all instances of that service and to scrape its metrics. Like that was it. So like that's so useful, like not having to custom configure Prometheus every time you launch a new app and then reload the configuration for Prometheus and stuff. I just thought it was really cool.
That's impressive.
It's the future. I love it.
It's ridiculously cool.
You know, when I was a kid, we used to have to write our own Kubernetes configurations for everything.
Yeah, that was exactly my thought. I was like, wait, what?
In YAML with no parser. Uphill both ways. All right, well, I'll go next for Free Software Friday. This is kind of cheesy, so you'll have to forgive me, but I want to call out Program Envy on GitHub because it inspired me to do a million things that I never would have thought of. I'll throw it in the show notes. It's github.com/program/envy. And I didn't even know how to describe it beyond a way to give yourself HTTP exposed and SSH exposed development environments that are backed by Docker and nested in a tree type structure. So you can have file systems that are shared by some of your environments and inherited from others and separate from others. I had so much fun with that whole thing, and it inspired me to do a million other projects that were very similar. So thank you for opening my mind on that one, Jeff.
Wow. Yeah, that's really cool.
Okay, I guess my turn. I am going to give a shout out to the Google Working Group Creative Commons. It is a really long-winded name, but it's a selection of courses about Go, and they are free. And I guess they're curated by Google or done by Google. I'm not clear on that yet.
That's awesome.
But yeah, it's a great resource because it's free and supposedly curated. So I'm looking forward to seeing people using this and see what feedback we get and getting more courses in there. I know Todd, I cannot pronounce his last name. Somebody help me. You know Todd, we interviewed him.
McLeod? Or yeah.
Yes. I know some of the courses that and he has such good feedback on his courses. Everybody loves his courses. So definitely, if you're looking to learn Go, you should check it out.
Awesome. Todd's got so much energy. He's fun to watch.
Yeah, he's a good person.
Jeff, was there any open source project you wanted to give a shout out to, or a person, or?
I've been trying to figure this out for a long time. Just since I saw the notes, I was like, oh, I'm going to have to pick one or two. Like even just two is hard. I don't know. I just because I touch it so much. All the stuff that most of the stuff that I forgot his real name, but SPF 13. And he did Viper and
Steve Francia.
Steve Francia.
Yeah. And
Viper
and
Cobra,
Pharaoh.
Yeah.
Yep.
And Hugo.
and Hugo, exactly.
Hugo, yeah.
Yep.
So speaking of all 3 or 4 of those things, I just merged your PR in Viper because I'm a maintainer.
Very cool. Thank you. Shout out to you.
Shout out to you for merging my PR.
That's great. Now my tests won't fail. Open source in action. Live.
There. It's not the PR you send, it's who you know.
Mm-hmm.
And apparently podcasts have something to do with it too, because this isn't the first pull request that's got merged by people.
Well, real time. Real-time pull requesting right here on Go Time.
The way it usually works, though, is somebody calls out the other person and then they do it live.
That's awesome.
If there were more people in the Slack, that would be a great time to request me to do any, because I have a bunch of projects that I don't. I just hope I don't even check up on them. I hope that the people that I've given commit access to are sharing it, and there's enough maintainers that they still work. I don't know that that's always the case. There's a strange plane outside. But I guess nobody can do that, so I'm safe. None of you have PRs that I need to merge.
No, we
Do you?
would have long called you out on that.
First thing,
Well,
yeah.
welcome to the show, Jeff. So, about my PR.
Mhm.
Didn't we do that once? I swear we did that once.
Carlicia
Like-
did it to Brad Fitzpatrick.
That's right.
Yeah.
You're awesome, Carlicia.
Yeah, it was fun. I'm a trendsetter. That's how it should always be.
Well, when you get somebody's attention, you got to get what you can get, right?
Absolutely.
Thanks for coming on the show, Brad. PR number 62. Let's talk about it.
Yeah, efficiency.
That's right.
I mean, maybe that's how you find new people to have on the show. People can just say, "Man, I really want this PR merged. Why don't you have them on your show?"
Yeah, absolutely. What are they
brilliant.
going to say? No. Of course, I'm going to merge it right now. Good or
Then
bad.
the problem becomes that people start using it in reverse and they come on your show and then ask you to merge their PR.
Oh, that's a good point.
Yeah.
Well, we can always cut their sound and.
Oh,
Cause yeah, when was Brad on the show?
a
So
few
what-
episodes ago, maybe 10 episodes ago.
Okay, I just need to check your backlog.
Yeah, it's been a couple months.
Yeah, I'll go back and listen to some of those episodes.
It was April, Brian. It was way more than a couple months.
Yeah, episode 44.
Oh, wow.
Yeah.
It's a long time ago.
Okay, so maybe it was a little more than 10.
Doesn't it feel good to have all this body of work, that you've accomplished? You forget about some of those episodes. It's like, oh, cool.
We've done some killer shows. We really have a lot of fun too.
Yeah, it's quickly approaching the territory where like you'll think about somebody who did something exciting. You're like, we should have them on the show. And you're like, oh no, we had them on the show. Like
Yeah,
Yeah.
we've already done that. Yeah.
We haven't had repeats yet.
we have not.
And there's plenty of time to go before we get there too. I mean, we're only 62 episodes in, and there's a whole lot more than 62 people doing awesome things in Go.
Totally.
True.
What's changelog proper at? They're like 400 or 300 or something. I don't even know.
I don't know.
273 episodes.
Wow.
Yeah,
Squad goals.
that is a lifetime. Steve just called out that Scott Mansfield was on twice, once as a guest and once as a host.
That doesn't
but
He
that
might have
count.
been on.
Doesn't count.
If that counts, then we've all been on more than twice too. Sorry, Steve.
Yes.
Go home.
I've
Go
been
home,
more
Steve,
than
you're drunk.
twice.
Wait, are there guest hosts?
Yeah, every once in a while, since everybody travels, we often get guest hosts. If you want to be considered for that, just let us know. We always need a stand-in on standby. A stand-in on standby.
All right. So I think that we have a hard stop in like 2 or 3 minutes. I think that the producer pulls the plug then.
Yes, 2.5
So-
minutes.
So we should probably wrap this thing up with a bow pretty cleanly. So huge thank you, Jeff, for coming on the show. It's been a blast, and now I have more things to play with because some of these projects I weren't even aware existed. I've been that out of touch.
Thank you for having me. And I mean, part of it is I don't share a lot of this stuff, so this is a great opportunity for me to talk about some of it.
Thank you, Jeff. It was great.
Thanks, Jeff.
Thanks, everybody.
See ya.
All right, that's it for this episode of Go Time. Tune in live on Thursdays at 3 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. Follow us on Twitter. We're at GoTimeFM. Special thanks to Fastly, our bandwidth partner. Head to fastly.com to learn more. Also, Linode. We host everything we do on Linode servers. Head to linode.com/changelog. GoTime is edited by Jonathan Youngblood, and the theme music for GoTime is produced by the mysterious Breakmaster Cylinder. We'll see you again next week. Thanks for listening.